Okay, has anybody looked at assignment 4 yet? Assignment 4, yeah. Anybody, you've started it? No? I recommend you start it as soon as possible because there's little things that can cause problems that have nothing to do with the assignment. You know, unzipping the thing and knowing which directory it was unzipped to, for example, that can be annoying. And there's different ways of unzipping under every version of Windows. So so look out for that. Yeah.
There's still a lot of syntax and just logic with regards to classes that I'm sure some other people, but I don't understand.
Yeah, so we'll be doing classes, more classes today, turning some of our games into object-oriented design, so using objects and classes. So hopefully that'll clear up. Any other comments about that? So just one quick thing I would like to show you about the assignment is. So if you unzip it, this is what you get. One file and 2 directories. Don't look inside those directories because there's thousands of files in there. The MP3s directory contains not complete MP3 files, but just stubs. In fact, just the headers of MP3 files. Maybe there's a fraction of a second of sound there, but certainly not whole songs. You can play them all together. I think it's just going to sound like random clicks and beeps. Most songs don't start out with a loud bit. And you'll see this directory called Mutagen, which is a library for dealing with all kinds of audio file formats, and in particular for reading the tags, the information that's in those files. So if you look at this program, this is just the code snippet that's included in the assignment. So what does this code do? You don't have to understand how all of this works. You just know what it does because you want to do something similar. It imports OS-specific stuff, and then it imports a few things that it needs from Mutagen. And this is an interesting recipe here. You can, a fairly common thing is to take a directory that you have and try and enumerate all the files, all of the subdirectories, and everything that's in that directory. So, so for example, what we're doing here is you give this thing a directory name. That's this dot here. And what does dot mean when you use it as a directory name typically? Yeah. Yeah, so it's the current directory, the directory you're running from, the current working directory. And then there's this OS walk thing which enumerates all this stuff, directories or files in there. We want to do something for every file, so that's what this does. This says for every file name in that list of files, we check if it ends with .mp3. If it does, we turn it into a path. So we take the directory, which is actually this dot, and then whatever's left of the file name, we print it, and then we use this Mutagen library. And so what do we do with that? Well, we call this method in the library. It's called mp3. That's what we imported up here, and that's for opening an mp3 file. So let's actually try that out. So we want to open a file, and so in that directory mp3s, I know there's a file called 1.mp3. So that's what happens when you open it. You get this weird structure. We'll see actually starting on Friday what this structure is. It's what's called a map, or a dict actually for dictionary in Python. So if you look at it, it's kind of strange looking. It looks difficult. But a a map or a dictionary is always something that takes a bunch of keys and maps each key onto a value. So for example, or you think of these things on the left maybe as properties, and then the maps them onto their value. So for example, there's a key in here called TIT2, and it maps it onto this weird looking thing, which it turns out is a Unicode string. That's not something we want to have to deal with, so we can just turn it into a regular string, and that's what you want to do for this assignment. So really the interesting part of that is this, which is the title of the song, the track. So how would we get that? Well, we say audio at, this is the key, the string TIT2. And we convert that into a string. And that gives us the title of this, the song that's in this file. If you want the album that it comes from, it's at talb. And I don't know if there's anything else we want. There is a release date there. I don't know if the assignment needs that, but there's other information there. Some of it you need for the assignment, some of it you don't. Okay. So so the assignment asks you to make these classes that represent things like tracks, which are songs basically, and they represent things like albums, which have a title, maybe a release year, and a collection of songs associated with them, so a collection of tracks. And so it asks you to make these classes to model this. And then sort of the last part of it is you load up, you use this MP3 library mutagen along with these sample files to load up this entire list of 5,000 or so tracks, figure out which albums each one belongs to, organize all that into this this data structure, and then implement an interactive library with that, where you can search for songs based on their title, or albums based on their title, or artists based on their title. So that's what you're working towards. So the first two parts of the assignment are fairly easy. They're just defining classes, and we'll see a little bit more how to do that today. The second two parts are, so one is implementing this program that allows you to search for things based on whatever the contents of the title or the contents of the artist. And then the last part is loading all of that information in from a file. So it's a fairly big project. You know, it's not huge. You're not making an industrial strength MP3 library organizer, but I mean, it's what you end up with is something pretty useful at the end of it. So so it's going to take some effort to do this and get all of the details working properly. Okay, so any questions about that? No, it's all good, it's all easy. And of course, this A4 test is at least for the fourth part of the assignment, where you actually need to do this. This is your starting point, because the assignment says, you know, write a function that takes a directory as an argument and scans everything in that directory and loads all the MP3 files and loads them into track, returns a list of tracks and albums. Okay. Don't want to do that there. So last class was 28th, right? September 28th. Okay, September 27th. So we had just started, we had done a bunch of experiments looking at is versus equals, so identity versus equality. And we'd made these pictures where we showed these little squares, these little boxes that are variable names, and deciding whether some value that we assign to that variable, whether it fits right inside the box or whether what's in the box is just a reference to something somewhere else. And we kind of figured out that for really simple things like integers, character strings, which are really short, 1-character strings, sometimes 2-character strings, those fit inside the box. But most of the more sophisticated things, big integers, for example, long strings, arrays, when you assign one of those to a variable, all that happens is the array is somewhere else and the variable is just a reference to that array. And that has these implications for things like, well, if two variables refer to the same array, then changing one of those changes the other one. And then we had just started to play around a little bit with defining objects. So, so this was, I think, a question someone asked me at the end of the class. So we talked about this person object that, or this type of object called a person, and we said that, well, you know, basic attributes of a person are a first name and a last name, and we created this weird looking, so, you know, we declared person, we said a person is a kind of object, and to initialize a person, that's what this underscore underscore init underscore underscore function is supposed to do. We set the person's first name to the first argument provided, and we set the person's last name to the last argument provided. And we said if you want to print a person, so we can define a method called printIt that just prints a string which consists of the first name, a space, and the last name. Yep.
Where did the self come from?
Okay. So every time you work with objects in Python, and this is true in other languages, but the other languages sometimes hide it a little bit better. So every time you make a method that works for an object, it always takes this extra argument at the beginning called self. So and actually, oh no, let's keep that. Okay, so the way you create one of these persons is you call it as if it's a function. And what are the arguments to that function? They're actually these arguments to this init method. Okay, so when you say person and give it 2 arguments, it really calls init, and it actually gives it 3 arguments. The 2 arguments you provided, first name and last name, as well as this self thing, which is really the object that's being created here. So we do that, and then I can look at me's first name, and I can look at me's last name, and so indeed I see that this is a person, and I can call me.printit, and it prints it. It calls this function here. So this syntax here, me.printit, is really just a shorthand for the following. It's the same as calling the function printit inside the class person using the argument me. So you ask what is this self? Where does it come from? It's actually this thing that's on the left side of the dot when you call it. Okay, so in this case, self is me. Okay. And when you call init, self is the newly created, the object that's newly created by this call. Okay. So an object is really this blob of stuff, things like first name and last name are, for persons, first name and last name are in there, as well as a collection of methods that it can run. So, for example, printed is one of the things that you can do with a person. Yep. I don't think it's actually a keyword, but if you're doing any kind of object-oriented programming in Python, you always call that first thing self. So I don't think it is actually a keyword in Python, so I don't think there's anything stopping us from doing something like calling that XXX instead of self, except that everybody who is, we can just test that. So there's nothing special about that word self. It's just that whenever you do object-oriented programming in Python, the convention is that that first argument is called self. That comes from other languages. In fact, there's a language called self, which is an object-oriented language. If you've programmed in C++ or in Java before, usually that's called this. So that's the thing for those other languages. So in those languages, you don't actually explicitly put this first argument in. It's implicit, and instead they reserve a special word, this, sometimes self, to mean that first argument. Okay. So questions about that so far? Yeah.
What about the initialization function? How does that separate from the printf function? Like, how does that know that when you create that object, that function has to be called?
Okay, so that's a good question. So why does it call init? Why not some other function? And to answer that, and this is where your experience as a programmer starts to matter. There's actually a whole list. So one clue that there's something funny going on are these double underscores here. So we've seen those before. We saw them when we wanted to do something. We wanted to change the way Python worked. We did from underscore underscore future underscore underscore import division. And so things with double underscores usually are, the double underscores indicate there's some special meaning here, that this name is important. It's not just another module or just another function or just another whatever. And in this case, what I want to look for is Python. I guess built-in methods will do it. The data model is what we want. Okay, so if you look at the Python documentation and this so-called data model, there's a list of special functions methods you can define in objects that do special things. So for example, new, I don't recommend messing with this one, is one that's called actually to create the object. You don't actually want to create it yourself. All you want to do is let the system worry about creating it for you. All you want to do is initialize it. So here's the description of what init is. It's called when an instance of the object is created. The arguments are those passed to the constructor. And then it tells you what to do if this is a class which inherits from another class, and what you should do in that case. Delete when the object disappears, so when it goes out of scope. All kinds of notes and warnings about that one. Here's one that's actually really useful to us. Underscore underscore str underscore underscore. If you try and convert your object to a string, which is what happens, for example, when you try and print it, what happens is Python tries to call this built-in method called underscore underscore str underscore underscore str. So actually, a better way to do our person is to say we support this method string, and when we try and convert a person to a string, we will just return their first name, a space, and their last name. Okay? Or maybe we want to do something fancier, say what it is. Whatever you want to, however you want to do this. And so now when I test that, so I can convert me to a string, and I get this string. I can say me. Usually don't want to do this, but occasionally you have to. So I can actually also call it directly. That works as well. A lot of things call the string routine. So if I print me, it actually ends up calling that routine internally. So lots of stuff there. Another one in there is this representation thing. So the difference between converting to a string and converting to a representation is a string is something that you would print, that somebody would read it and understand, a user, let's say. A representation is something that looks like Python code. In fact, if possible, you should make the representation be Python code. So for example, we can do one of those. But before, let's see what happens when we don't have one of those. So when you inspect an object like this, all you get is this weird thing that says main.person object and some weird stuff here. But I can define this representation, which is supposed to return a string that is Python code that could create this person. So how do we create a person? Well, we call the person method. Let's see, the best, maybe like this. So just a slight variation on that. And we'll see how that works for us. So now, when you look at one of these things, you don't just get this weird thing here, you actually get this, which actually is Python code that would make that person if you wanted to. So, right, I can say him equals that thing. So notice the difference. One calls string, the underscore underscore str, gives you some string that you would present to the user, and the other one gives you something that's more useful to a programmer. Okay. Now, well, this is a good, this is actually a good time to check this. So I have me, and I have him. So remember, is the thing that tests if two things are identical. Are these two things identical? Are they the same object? No. Anybody think yes? They certainly look equal. They both have the first name Pat, last name Morin. So they seems like they should be equal, but they're not identical. And we really need to understand this. So why did this happen? Why are these not identical? Well, that's because I created me by saying person Pat Morin, and calling person Pat Morin creates a new object, a new person object, calls its init method, which so sets its first name and sets its last name. And then finally, once that's all done, we've evaluated the right-hand side of this assignment. We then assign the result to the left-hand side, and the result is just a reference to that object. Later, when I say U equals person Pat Morin, exactly the same thing happens. So we had me, now we're making U. So the new object gets created because we called person Pat Morin. We get an object that looks almost the same. Well, it looks exactly the same, but it is indeed a different object. And then a reference to that object gets assigned to U. Okay. So that's why they're not. That's why they're not identical. In fact, we could test that easily by doing something like me, you, him, sorry. I could say me dot first name equals Pedro. Now me is Pedro Morin, but him is still Pat Morin. So that's pretty much a proof that they're not identical. You change one, it doesn't change the other. Okay, but let's go back to put things back the way they were. What if I ask if me is equal to him? Should be true, right? If we go back to what we know, the things we've tested for identity and equality, well, we tested, for example, strings. And two strings, even though they're not identical, they're considered that they're equal if, you know, their characters are the same, they're the same length, and they have the same characters in the same position. We also did arrays, which the same rule applies, basically. If the two arrays are the same length, and they have equal values in each position, so the first array at position 0 is equal to the second array at position 0, and so on, and position 1 and 2 and 3, and so on, then they're considered equal. So by that sort of rule, or that heuristic, that means me and him should be equal, but they're not. So why not? Yep. They're different objects. And we've not defined in here, we've defined methods for initializing, we've defined methods for turning into a string, and we've defined methods for giving a representation of this thing. But we never said what it means for two people to be equal. And so what happens in that case is it just goes to the default behavior in which two things are equal if and only if they're identical. Now, it seems like we would maybe like to change this behavior. And so we go back to that list of all of the functions, different methods we can write, these special internal methods for objects. And indeed, there's a whole pile of them right here. LT, LE, EQ, NE, GT, GE. Actually, in particular, this one is important, equal. So these things correspond to comparisons. So less than or equal to, equal, not equal to, greater than, or greater than or equal to. Yeah? Sure. If you don't see it there tonight, send me an email to remind me. Any of you can do that. Okay, so so this suggests, if you read this documentation, it suggests, well, if we want to define what it means for two of these things to be equal, we need to write this method. We need to define this method. So let's go ahead and do that. So equals takes self and another argument called other. So self is the thing that's on the left-hand side of the equation, of the equality test, and other is the thing that's on the right-hand side of the equality test. We'll do a very simple one of these that's not perfect because I don't want to delve into too many mucky details right now. But what should it mean if two people are equal? So what's a reasonable way to define it? Yep.
Should each of their internal values is the same?
Sure. So let's say their first names at least have to be the same. So how do I express that? Yep. Self.first name is equal to what? Okay. And self.last name is equal to other.last name. Okay. So now these two things will be treated as equal if and only if they have the same first and last name. And notice we already reach a situation where we have a lot of decisions to make now. Should the two people be equal if their names are capitalized differently? I don't know, maybe not. You know, if you suddenly have a middle case, an uppercase letter in the middle of your name, is that different than if it's not there? I don't know, maybe not. That really depends on what application we'd want to use this for. Right now we're just playing around, so we'll keep it simple. So let's test all that out. So me equals person at Morin. Him equals person at Morin. Me is him. Nope. Me equals him. Yes. Him equals me. Yes. And if I do something like change his last name, so we have him, we have me. Are they still equal? No, because their last names are different. Okay. So is that clear? Now, I'm not going to teach you, there's no point actually because you won't remember them. I'm not going to teach you all of the methods that you can override here. Look at them all. They're all on this page. You know now that they're there and you know that this page exists. So when you run up against something and you think, oh, I'd like to define an object and I would like it to make sense, for example, to be able to multiply two of my objects together. So could I do that? So could I make two people and say, you know, me times him? Well, let's see. Indeed, if you want to make your object look like a number so that you can add things together and you can subtract things together, you can use them in formulas. In particular, if you want to do multiplication, you just have to override this method here. So for example, yeah, this lets you do something like, you know, me times him. So this doesn't work right now because we didn't implement mul and it says it's unsupported. We can't do this. If we want this to be supported, all we have to do is write a mul routine. What's that?
How would you multiply string type?
It's totally up to you. It's whatever you want it to be, right? So, what do you? Well, how would you multiply two people? I don't know. Maybe you make a child. Who knows? Yeah.
You're overriding the multiplication function, so you can do anything with that object when you do me times him. For example, you can make self equal, or self dot first name equal whatever.
Yep.
Right?
Yep. So, although I wouldn't recommend that. So if you think about what it means, so you could have that change self, or you could have it change other, but I wouldn't recommend it, because then you've done multiplication, which is doing something really strange. It's actually changing its arguments. And no other kind of multiplication does that, right? You add 4, you multiply 4 and 5, you get a third number that's 20. It doesn't change 4 into 20 or 5 into 20. You actually just get a third number. So I don't know, a more reasonable multiplication would be something like, I don't know, maybe multiplication is supposed to represent mating in whatever program application you're writing. So maybe you would do something like create a new person which has last name, its first name, or other dot first name maybe. And takes, I don't know. So there's a reasonable definition of multiplication. You create a child whose first name is the concatenation of its parents' first names, and its last name is the left-hand parent's last name. Let's see if that works. There you go. So, and notice that that's the way multiplication should work. Me and him were not changed by this act of whatever it was we were doing with each other. We just created this extra third person. Okay. So there's lots of these things, but basically almost everything in the Python language, so all the operators and all the comparisons and all of these things, when you apply them to objects, all that happens is they end up calling some specially named function inside that object if it exists, or they throw an exception saying that that function doesn't exist. So for example, we've defined multiplication, so we can multiply these two things, but if we try and add them together, it tells us that's unsupported. If we wanted that, we'd have to implement underscore underscore add underscore underscore. Okay. All right. So maybe we should. So now you know some syntax. Now maybe it's time to get on to maybe some applications and how you would use objects. And for that, I think it would be helpful to go back to our quiz game that we wrote last week. So remember this game, it loaded a list of questions from a file, and it then asked various versions of these questions. So there's this game, and it has questions and so on. And what you do when you're doing object-oriented programming, or when you want to make use of objects, is you try and find sort of chunks of data that are all related or naturally belong together, and then define an object that holds that sort of data. So in this quiz game, what are the candidates for objects? So what kinds of objects could we define for this quiz game? Yeah. That's the most obvious candidate. So question seems like a fairly obvious thing, right? You may or may not remember, but in this game, the way a question is represented that's this Q here, and let's say in this function display question, it's actually a list or an array of items. And it's a little bit annoying because you really have to know to know, you know, what this is all supposed to mean. You either have to look really carefully at the code and dig through it, or you have to open up the sample file to figure out what which parts of the array correspond to which parts of the question. And we saw that actually, even to figure that out, we had to look at a fair number of questions in the sample file before we could even figure out where the right answer was, which one was the right answer. So the way it's set up now, and it's not intuitive at all, is Q at 0, so if Q is a question, that happens to be the actual question itself, so the text of the question. And Q at 1 is a possible answer. Q at 2 is a possible answer. At 3 and at 4 is a possible answer. So those are the possible answers, and then Q at 5 and Q at 6 are these other two fields, which are the category and the level of difficulty. So it's all sort of appears here. You can dig it out from the code, but that's certainly not intuitive, right? If somebody just gives you one of these arrays, who knows what's there. So there's a natural choice for an object in our program. So we'll define a class called question. It's a kind of object. And, well, what's the sort of the first thing we have to do when we define a class? We want to initialize it. So we want to initialize a instance of this thing. And usually it's fairly good practice to take arguments in the init function that set up everything inside the object. And if you can avoid it, it's good to actually never change the object after that. There's a good reason for that we'll get into when we start looking at sets and dictionaries. But for now, let's just take that for granted. So it's much easier to write something like question, you know, A, B, C, D, or you know, Q at 0, Q at 1, Q at 2, and so on. So that's somehow a short piece of code, rather than create a new question and then say, set the question text to Q at 0, set the first answer to Q at 1, set the second answer to Q at 2. If nothing else, it means that we can do it in one line of code instead of 7 lines of code. So what should the arguments be to this constructor then? So what are the things that a question has? Yep.
We need the question.
So we need the text of the question itself. So let's make one argument called the question itself, and we'll say self.question is equal to that thing. Okay, what else? So maybe it'll help if we open one of these things up. So when we load these questions, we get an array called questions, or that we've assigned to a variable called questions, and has 646 elements. And if we look at it, Q equals questions at 0. If we look at one of these things, each one is itself an array or a list. So there's the text of the question, and then what's next? Yeah. The answers. So maybe we should split this thing up, and the stuff that we want is the question, the text, and maybe the options for the answers. So that could be, we can put some comments if we want. Text of the question, 4 possible options, or let's say possible options. What else is there?
The category and difficulty.
Yeah, so there's a category. And there's a difficulty. And I'll actually call difficulty, I'll call it level, because we already used the word level in our code elsewhere to mean difficulty. So we have a category, and we have a level, so a level of difficulty. And anything else? The right answer. So maybe we should say something like, we should also take self.correct option is equal to another thing that's provided to us. And this will be the index of the correct answer. Okay. Seem reasonable? I think that's everything. So let's start using one of these things. So first thing we do is load questions, and we load them from a file. How do we do that? We open the file, we split it up into lines. That gives us an array of lines, and then we go through that array and split each line up based on tabs, and that gives us an array of 7 elements for each line. So maybe we want to do this a little bit differently. Let's say we want to write a little helper function to turn an array into a question. So that's one of these arrays, like this array Q. We'd like to turn that into a question. So if we want to turn that into a question, what do we return? So how do we make a question, or how do we make a new instance of any object? So how did we make a new person? Yep. Well, actually, setting a variable to it is what happens after it's made. But how did we make it? So in other languages, you might call new or something. Yep. Sorry, I can't hear you.
How do you make it via terminal or by writing a line of code?
Same way, either way. So we use the init method, but we don't call it directly, right? Yeah? Yeah. So we just pretend, we just call question as if it's a function, and then we have to give it some arguments, because in fact, calling the class name as if it's a function really creates the new object and then calls init with that object and the arguments that we've provided. So, so if we look at this, well, the first thing we need to do is provide it with the text of the question. We've seen that. that's the 0th element of that array. So the first argument should be A at 0. The next thing we want to give it are 4 possible options for an answer. So those are A at 1, 2, 3, and 4. So we want to give it an array that consists of A at 1 through 4. How do we do that? Yep.
Is that just A and then within the square brackets, 1, 5?
Yep. 1:5.
Yes.
Yep. So this says, give me the array elements 1, 2, 3, 4 as an array. Right. This is this array slicing that we've seen before. Okay. So that's the options. Then we have to specify what the correct option was, and this should be the index of the correct answer. So what's the index of the correct answer in this array that we've just passed? 0. It's the first one. So in Q, its index is 1, but in this array that we've just created that starts at 1, it's actually an index 0. Okay. Then we need to specify the category, which was A at 6, 5, and then the difficulty, the level of difficulty, which is A at 6. Okay. So now, when we want to load up our questions, we proceed exactly the same way. We split this file into lines. For each line, we split it into tabs. That gives us an array, and we want to take that array and turn it into a question. Okay. So that's a lot of code to write without testing. Let's see how many mistakes we've made. Okay, so questions is still an array with 646 elements. But if I say Q equals questions at 0, what's Q? Well, it's an object, and it's a question object. So since it's a question object, I can ask to look at the parts of it. The question. So there's the question. What are the options? There's the 4 options. What's the level? What's the correct option? It's option 0. And what was the other thing? Category. Food and drink. Okay. So we now have this giant list of questions now. Things are nicely formatted. It's not just a list of arrays, but it's a list of actual questions. Okay. So we've gotten this far into our code. Now, if someone asks us to display a question, we'll get rid of this permuting business for now. We'll just display it as provided. So the first thing we do is print the category and the difficulty. So that's just Q.category and Q.level. Next thing we do is print the text of the question. That's just Q.question. And then we print the options for the possible answers. And that's just Q.options at I for I is 0, 1, 2, and 3. Now let's test that. So there, we've now made that function a little bit more object-oriented. We've displayed our, we've gotten our code up to this point to work with these objects, and rather than these raw arrays. And now, if you look at this code, it starts to become a lot cleaner, right? It makes a lot more sense. It's a lot easier to remember that if I want the question, the actual text of the question, that's called .question rather than @0. And it's a lot easier to remember that if I want to know the category, that's called q.category rather than q@5. So it makes the code actually more readable and clearer to see what's going on. So next thing we might want to change is input answer, but input answer doesn't do anything. It's just an input routine. It doesn't depend at all on how questions are represented. So what's left is to make our game work with this thing. Okay, so we load the questions. So now this thing is no longer just an array of arrays. It's an array of questions. We do this level. Then we pick a random question from this array. So Q now is a question object. It's not an array anymore. And then we checked if the level at Q was appropriate. So what should we do here? So we checked, yeah.
Or Q.level.
Yeah, so we should use Q.level instead. In fact, maybe we should clean things up earlier on. So here we converted that to an int, and that's because we actually made a mistake. The first time we did it, we forgot to do that. And remember, this is the stuff that's read from a file, so it was actually a string. And so maybe when we read this from the file and create this thing, so level of difficulty, we should specify that we want this to be an int. And here, when we create a new question, we'll make sure we pass in an int. So that makes this a little bit simpler too. So as long as the level of the question that we just picked is not equal to the level that the player is playing at, we'll just try and pick another question. We said we're going to ditch this whole permuting business for now because it makes sense to put it somewhere else, so we don't need to shuffle it. We want to display the question. We've already wrote the code for that. Then we want to read the answer, and then we want to check if the answer is correct. So how do we know if the answer is correct? So the user has input a number between 1 and 4, and it's stored in this variable ans. So when is that correct? Yep.
Would it be if Q dot options equals 0?
Not exactly. Remember, in our question, we are storing the correct option.
It's always 0.
It's so far it's always 0, but there's a possibility for us to change that later. And so if we're going to refer to it, we shouldn't hard code a 0. We should use this correct option value of this thing. So really what we want to know is if they picked Q dot correct option. And it's actually not exactly that, because we're asking the user to input answers that are 1, 2, 3, or 4, but internally these are stored in an array at position 0, 1, 2, and 3. So we need to subtract 1 from the answer that the user gave us. Or if you don't like that, you can subtract 1 here. Okay. So if their answer is the correct option, then we say correct, great work, and we increase their score, and by 1,000 times, and what's Q at 6 again? It's the level of difficulty of the question, which has a new name now. It's Q.level. And if they're wrong, then we want to print the correct answer for them. So what's the correct answer? Used to be Q at 1. It's Q dot Is it Q dot correct option? So let's see, we create a person here, and we say the correct option is 0, right? That's what we passed in as the value of the correct option, 0, the 0th element of the array. So Q dot correct option is just this integer 0. Yeah, so if we print Q dot correct option, it's going to say wrong, the correct answer was 0, which is not that helpful to the user. What we want is Q dot options at the correct option. No, because correct option is stored based on 0. Okay. The only thing where we're off by 1 is this. When we get the user input, it's off by 1, and we display the question, we add 1 to these indices. Alternatively, if we're lazy, we could just make the user enter 0, 1, 2, or 3, but users generally don't like that. Okay. So with any luck, we've ported everything. Let's see. Okay, how many instruments accompany someone singing a cappella? 0. Who released the best-selling album American Idiot in 2005? Green Day. Yeah. And what was Skippy? Let's say he was a horse. Wrong. The correct answer was kangaroo. So it seems all our logic is still working. It tells us whether we got the right answer or the wrong answer, and it also it displays things correctly. It does the indexing, going from 1-based indexing to 0-based indexing. All of that seems to work, but we did lose a feature of the original game, which is actually a really important feature, and that was the shuffling the answers, or more importantly, not having 1 always be the correct answer. And before, that was something we did by creating this permutation array that was a permutation of the integers 1 through 4, and then using that to, whenever we're printing questions, to index it, and whenever we're reading answers, we use that to reverse it, and there's sort of this weird logic to do that. But now that we've defined a question, there's no reason we can't do that here in the constructor for the question. So we'll do something like, say, the answer is equal to self.options at self.correct option, or if you like, we don't even need that. In fact, we don't even need that. We can just say opt. So let's save that answer. Right, these are the options that the user gave us. Opt. This is the correct option, and we'll just save that and put it aside for now, because what we're about to do is shuffle self.options. Okay. So after this, all of the options are now mixed up. Now, yeah, shuffle comes from the random module. It takes a list as an argument and shuffles its elements in place. It modifies the list. Okay. And now, is this still the correct option anymore? No. So the correct option used to be COR, or 0, but it's not anymore because things got all moved around. But we did save the correct answer. So what we want to do now is go through this shuffled list which is called self.options, and look for this thing, this answer that we've saved. And it turns out if you look through the list documentation, lists have a method called index that returns the index in the list of the first item whose value is x. So that sounds like what we want, because what we have here is a shuffled list, self.options. We know that the correct answer is in there somewhere, and what we would like to save is its index. So we do self.options.index, and we want the index of the correct answer. Okay. So that will find the correct option in that list of length 4 and return us the index of that option, which is exactly the thing we want to save. Okay. Is that clear? So it's like we play, it's literally like shuffling a deck of cards. So I show you the cards. I say, pick a card and remember it. Then I take the cards away, shuffle them. Then you can look through that shuffled pile and find out, find the card that you remembered. Yeah.
Don't you need to import something when you use the index function?
No, index is built into lists, which are part of the real default Python library. So we use lists all the time in Python, so they're all part of the default. Okay, so let's see if that works for us. So somehow this is where things become a lot less fun, because now we don't know the answer. So what's the answer to this question? Winnie the Pooh, you say? So, wrong. The correct answer was Winnie the Pooh. So Kanga is the young kangaroo, I think. Oh, that's Roo, okay. All right. Who lives at Home Hill? So somebody really, with a lot of somebody has to be stronger than the rest and convince me. I'd have no idea. 1. Correct. Great work. Nana is from? It's the dog in Peter Pan. And which band is fronted by James Bradfield? That's only difficulty 1.
Yeah, if you're from the 80s.
I don't even know. Even then, I'm from the 80s. I don't know the answer. What was a hit song for Lulu? I don't know. Scream, shout, and we lose. Play again? All right. Which tube station was a hit for the Kinks? So, well, okay, so the genre is music, so I guess the Kinks are a band. What's a tube station? It's a subway station in British English. So it's difficult to parse this without context. And what was a hit? So I don't know. 4. Wrong. Waterloo Sunset. Should have let me put in 3. Eurythmics? Yeah, everyone knows this one. Simon and Garfunkel sang about Mrs. Robinson. Cuckoo, cuckoo. Somebody play tennis here? Which Stanley Kubrick film is based on a novel by William Makepeace Thacker? It must be Barry Lyndon.
Probably
No, Lolita's by Nabokov. Which film does not star Jessica Lange? King Kong? Wrong. Fried Green Tomatoes. Who composed the music for West Side Story? Correct. We're doing really well this one. What does James Bond smoke?
Oh.
All right, we're at level 3. What was the name of the secret organization in the TV series UFO? Spectre? Shadow. Game over. Pretty good though. Good run. No. Anything else in this game that you could turn into an object? Any obvious thing? Yeah, so a common thing is to take all the stuff about the state of the game and maybe store that in one place. So here it's not such a big deal. This game really only has 2 pieces of state: lives, score, and well, level is computed based on score. So you could very quickly define something called a game state. And the only thing I want to show you here is the use of default parameters. So here's something you haven't seen before. Functions in Python can take a default argument. You just write it like this. In the list of arguments to the function, you just say equals 3. And then if it's not provided, that'll be the default. So by default, the number of lives is 3 and the score is 0.
So does that mean you have to do them in that order?
Yes.
But like if you skip one, you can't really skip
You
one.
can't skip the first one and include the second one. So state is a new game state. We don't have to give it any arguments. And then anytime we use the score, we have to say state.score. And anytime we change the lives, we have to say state.lives. We use score to calculate the level. Good catch.
Could you just do like a search for score and then replace pretty much all the scores with?
Yeah, you could try that. And here we missed it, line 47. Right at the beginning, one line after we created this thing. All right, last round. What's the answer? No. It's going to be a short one. Elvis? No. Gallagher. Last one. Wrong. He was a paleontologist. Terrible. So now, tonight is the best time for you to work on your assignment.